Next problem. Show that the points P A comma B plus C, Q B comma C plus A, and C and R C comma A plus B are collinear. So given points are P, Q, R, right? So first method, to show the given 3 points are collinear, it is enough to prove slope of PQ is equal to slope of PR. So we know that slope of any line joining the 2 points x1, y1, x2, y2, that is 2-point form of a slope. So m, which is equal to y2 minus y1 by x2 minus x1. So to find slope of PQ, here P is equal to A comma B plus C, that is x1, y1, x1 equal to A, y1 equal to B plus C, and Q is B comma C plus A, so x2, y2, x2 is equal to B, y2 is equal to C plus A. Using that slope formula, slope of PQ, which is equal to C plus A minus B plus C by B minus A. So C plus A minus B minus C by B minus A. So that is so plus C minus A get cancelled. So in numerator A minus B by B minus A. Taking minus outside from the numerator, so minus B minus A by B minus A. So get cancelled, you will get minus 1. So slope of PQ is minus 1, that is 1. Next we have to find the slope of PR using the same formula. Here P A comma B plus C, that is x1, y1, x1 equal to A, y1 equal to B plus C, and R C comma A plus B, x2, y2. So x2 is equal to C, y2 is equal to A plus B. Using that formula, slope of PR, which is equal to A plus B minus B plus C, y2 minus y1 by x2 minus x1, C minus A. So A plus B minus B minus C by C minus A. So plus B minus B can cancel. So in numerator A minus B by C minus A. Taking minus outside from the numerator, so minus C minus A by C minus A. C minus A and C minus A get cancelled, you will get minus 1. That is equation number 2. So from 1 and 2, slope of PQ, which is equal to slope of PR. Therefore the given points are collinear. So next method, we are using the determinant method. So we know that given 3 points x1, y1, x2, y2, x3, y3 are collinear if the area of the triangle with vertices x1, y1, x2, y2, x3, y3 is 0. So area of the triangle we know 1 by 2, determinant x1, y1, 1, x2, y2, 1, x3, y3, 1 equal to 0. Here x1, y1 is A comma B plus C, that is x1 equal to A, y1 equal to B plus C, and x2, y2 is equal to B comma C plus A, x2 is equal to B, y2 is equal to C plus A, and x3, y3 is C comma A plus B, x3 is equal to C and y3 is equal to A plus B. Substituting this value, area of the triangle, which is equal to 1 by 2, right? A, that is x1, y1b plus c 1, and x2b y2c plus a 1, x3c y3 a plus b 1. So that is equal to half into first a into, right? So we are going to solve the determinant. So first row, first element a into, so you have to take the second row, second element, and third row, third element, right? So c plus a into 1. Then you have to put minus second row, third element, and third row, second element, right? So minus a plus b into 1. Next term, you have to take the first row, second element, b plus c. So you have to put minus, right? So minus b plus c into, so you have to take the second row, first element, and third row, third element, right? So b into 1, then minus, you have to take third row, first element, and second row, third element, c minus c into 1, minus c into 1, then last one, first row, last element, plus 1 into, right? So you have to take second row first element, third row second element, b into a plus b, then minus third row first element, second row second element, minus c into c plus a. So solving this 1 by 2, a into c plus a minus b minus b plus c into b minus c, plus multiplying with b, ab plus b square, multiplying with minus c square minus c into a, which is equal to half a minus a get cancelled, so you will get c minus b, minus b plus c into b minus c, so a plus b into a minus b formula, a square minus b square, here minus b square minus c square, plus ab plus b square minus c square minus ca, that is equal to half ac multiply with a into c minus ab minus b square multiplying with minus into minus plus c square plus ab plus b square minus c square minus ca. AC minus ca get cancelled, ab minus ab get cancelled, minus b square plus b square get cancelled, c square minus c square get cancelled. So 1 by 2 into 0, that is equal to 0. Therefore area of the triangle formed by these three vertices is 0. Therefore these 3 points are collinear. Thanks. So in another method, we can do row reduction method, right? In determinant we can use this method to solve, that is shortcut method to solve the determinant, right? Now area of the triangle with vertices PQR, which is equal to 1 by 2 x1 y1 1 x2 y2 1 x3 y3 1. Substituting the value, that is equal to 1 by 2 a b plus c1 b c plus a1 c a plus b1. So first row, that is what, capital R1, second row R2, and third row capital R3. I marked in the right side of the determinant. First operation, so this is equal to 1 by 2, keeping first row same, R1 equal to R1. So first row as it is a b plus c 1. Second row becomes in this, so second row of the previous one minus first row of the previous one, so R2 minus R1. So b, you have to subtract the corresponding elements, b in the second row and a in the first row, b minus a, and c plus a in the second row, b plus c in the first row, so c plus a minus b plus c, and 1 in the second row, then 1 in the first row, so 1 minus 1, right? Next operation R3 can be written as R3 minus R1, so R3 row 3 minus row 1, so you have to subtract the corresponding element. In row 3 you are having c, right? And in row 1 corresponding element is a, c minus a. In row 3 the second element, right, is a plus b. In row 1 second element is b plus c, so a plus b minus b plus c. In row 3 third element is 1, in row 1 third element is 1 minus 1. So this is equal to half determinant a b plus c 1 first row, second row b minus e b minus a c plus a minus b minus c 0 1 minus 1, third row c minus a plus b minus c 0, which is equal to 1 by 2 a b plus c 1, that is equivalent to, right, first row. Second row b minus a c minus c get cancelled, a minus b 0, and third row c minus a b minus b get cancelled, a minus c 0. Again we are going to do the row reduction idea. So keeping the first row as it is, R1 is R1, right? I am writing this in the right side of the determinant, that is the operation what we are doing, right? So half equivalent to half first row as it is, row 1 is row 1. The second row is second row of the previous one divided by b minus a. So previous one second row first element b minus a divided by b minus a. Second row second element a minus b by b minus a, 0 by b minus a, that is 0. And R3 is R3 by c minus a. Third row first element c minus a divided by c minus a first, right? A minus C, second element of the third row, by C minus A. 0 by C minus A, 0. So that is equivalent to 1 by 2, first row A, B plus C, 1. So B minus A, 1, right? So taking minus outside, minus B minus A by B minus A, second element, third element, 0. And third row, first element, C minus A by C minus A, 1. Taking minus outside, minus C minus A by C minus A, and third element, 0. Which is equivalent to first row of into A, B plus C, 1, 1, then B minus A get cancelled, minus 1, 0. Then third row, 1, minus 1, 0. If two rows are identical, then the value of the determinant is 0. That is the property. So we are using that property. So the value of the determinant is 0. Therefore, the 3 points are collinear. Thanks.